So this is notes 10.5. This is the Pythagorean theorem. We're going to use the Pythagorean theorem to solve problems and also to determine whether a triangle is a right triangle. You got to know what a hypotenuse is, a leg is, converse, and there are some things called the Pythagorean triple. If a triangle is a right triangle, turns out that the hypotenuse, which is the longest one, hypotenuse, it's the longest side on here, and that's always C. C is always by itself in this formula. One way to remember the hypotenuse is it's always across from the 90-degree angle. So if you turn the 90-degree angle into an arrow, it points right at the hypotenuse. And it turns out that if you square each of the leg lengths and add them together, that equals the square of the hypotenuse. So here's what we do to use this. For this one, I've got 18 as a leg. That's going to be my a squared. And I'm going to square it, and then 24 squared. That'll be my b squared. And this equals c squared, which we don't know. So to solve this, I'm going to take 18 and square it. And I'm going to add 24 squared to it, and I get 900. So we're going to have to undo the c squared. So just think about this, c squared and the square root of c squared are the way that they're related to each other. So if I want to undo this, then I'm going to do this, because the square root of c squared is c. But to do that, you have to do it to both sides. So if I'm going to undo the c squared and turn it into just c, then I need to do the same thing to the other side. So the square root of this one is 30. So c equals 30. So you try this one. Let's see if you can do this. Pause the video and then come back for the answer. Okay, check it out. Here's the answer. One thing that's different about this opposed to this one, as opposed to this one, I didn't have a variable on the left side, but on this one I do have a variable on the left side. So what I'm going to do to solve that is I'm going to isolate the b squared by taking away 81 from both sides. So that's what happened to get 175, and then the process is the same. You just take the square root of b squared, square root of 175, and you get 123. We talked about earlier how a solution to something like this was in the last chapter, would be the square root of x squared equals plus or minus the square root of 5. That is still a thing. So x equals -5 and +5. But the difference here is we're just talking about length. So we only want the positive square root for length. Okay, so this is still a possibility, but since we're talking about length, then that's what we do. All right, Amareta is hiking out directly east from her camp on the plains. So we've got to pay attention to what's north, south, east, west, north, east, west, and south. And these are 90 degrees to each other. So she walks 6 miles directly to the east. And then she turns right and walks 7 more miles to the south. And then we have to figure out how much further she has to go. So you have to figure out what these lengths are. That the c is the distance back. I know that because this is 90 degrees and the c is always across from there. So you're going to use Pythagorean theorem again. And we get 85 equals c squared. Take the square root of both sides, and c equals 9.2 miles. So the converse of this enables us, and they write it with the c squared equals a squared plus b squared. The way we just did it, that's a little bit more familiar to some of you, but this is the way we use this in geometry. If the hypotenuse squared equals the sum of a squared and b squared, then it's a right triangle because it fits the Pythagorean theorem. If it doesn't, then it's not a right triangle. So we're going to try this. First thing is to identify the c. C is the hypotenuse. It's the longest side, so this is c. So we have to verify that 7 squared plus 12 squared equals 225. Oops, 15 squared. So does 49 plus 144, which is 193, does it equal 225? No. So the answer to this is it's not a right triangle. But when you get to the next one, okay, this is a 55. That's the hypotenuse. I know it is because these two are shorter. We have to check and see if 33 squared plus 44 squared equals 55 squared. And if it does, then this is a right triangle. And when we go through the math of this, this is going to be 3,025 on both sides. Oh, that's a terrible 2. There you go. Yes, this is a right triangle. This brings me to Pythagorean triples. There are some sides that definitely are always right triangles. If I have legs of 3, legs of 4, and a hypotenuse of 5, I already know it's a Pythagorean triple. It's makes a right triangle if those are the lengths, because 3 squared plus 4 squared equals 5 squared. Check it out and you can see. So if 3, 4, 5 makes a right triangle, if I multiply each of these by 2, 6, 8, 10, turns out that this is a right triangle. If I multiply these each by 11, I end up with 33, 44, 55. Look familiar? So no matter what you multiply the 3, the 4, and 5 by, as long as you multiply by the same factor, you're always going to end up with a right triangle. Another one is 8, 15, and 17. And the other one I remember is 7, 24, 25. There are many more, but those are the basic ones that often, frequently are used in your assignments here and in geometry. All right, so that's the end of this. So you should know how to find the missing sides using this formula, but also you should know how to check whether it's a right triangle. And that would be Pythagorean theorem. All right, see you later.